Hey everybody, this is your tutorial on solving quadratics, and I'm really going to be targeting two main methods of solving quadratics. I'm not going to be talking about the quadratic formula. That can be used for every quadratic when in standard form. However, we're just going to be looking at the square root method today and factoring. Here's the two equations that I'm going to look at, and the first thing you have to be able to do is determine which method is going to work with which equation. One indicator would be, for example, on the first one, you see that we have a quantity squared, right? The quantity being indicated by the parentheses, and then the squared is on the outside. When you have that, that's going to indicate that you're going to use the square root method, versus the second equation, where you have individual terms squared. You're not going to be able to use the square root method most likely there because actually you have another a value there. Okay, so not only do you have an a squared, you have an a. So this indicator is going to be telling you that you're going to have to use the factoring method or the quadratic formula. But like I said, we're not going to use the quadratic formula today. So let me get going on the square root method. Alright, so undoing order of operations, we're going to be subtracting 4 first from both sides. And then we will divide both sides by 6 to reduce the multiplication of 6 to the quantity. And that turns out to be 49. Now this is a really important part right here because anytime you have something squared and it's equal to a number, there are two values that actually make this equation true. For example, let me give you a little thought bubble here. If you have x squared equal to 4, there's two numbers that actually make that true. 2 squared would give me 4, but also negative 2 squared would give me 4 because squared means you're multiplying some number by itself twice. So negative 2 times negative 2 would still come out to be a positive 4. So I know that x is going to equal 2, and x is also going to equal negative 2. You could also write this as x equals plus or minus 2. And the operation that does this is square rooting both sides, okay? But make sure you keep the plus and the minus. So in this case, we are going to square root both sides. And then the square and the square root, they reduce themselves because they are inverse operations. Then we have v plus 3 equals, now we're not just going to have 7 here, we will have plus or minus 7, keeping both values in the solution. Because I know 7 squared is going to give me 49, and also negative 7 is negative 7 squared will also give me 49. So now I have to go two routes here. I know that v plus 3 will equal positive 7, and I know v plus 3 will also equal negative 7. So in both cases, when you subtract 3 from both sides, you're going to end up getting, this one's a little scrunched, v is going to equal 4, and then in this case, v will equal, sorry, this should be negative, negative 10. Okay, so those are your two answers. And that's how you'd use the square root method. Now looking below, we're going to have to talk first about the process of factoring and what we're going to end up doing. So it all boils down to this. If you have two quantities and their product is equal to 0, the only way that can happen is if one of those quantities, if not both of them, is going to be equal to 0, because 0 times any number is going to equal 0. So I know that both of these, or one of them, has to equal 0. So what we want to do is we want to get this in factored form. Factored form just means there's a product. A product is multiplication of two factors, and those are your factors. So that's why it's called factored form. In order to do that, what you see is that we have to first get the equation equal to 0 in order to apply this property, which is called the zero product property. So in this equation, I'm going to first get all my a squared terms on one side. So I'm going to do add 4a squared to both sides. I'm also going to subtract the 7 over. So I'm going to do 2 steps at one time. So now I see that my 7 will reduce and my negative 4a squared will turn out to be 0. And what I'll be left with, I'll have 1a squared left over, so a squared plus 6a subtract 7 equals 0. Now my goal is to take the left side of my equation and write that in factored form. So for quadratics, there's several different techniques you can use in order to factor this. One method, if you were introduced to FOIL in junior high or elementary school, that's just when you have 4 terms and you distribute, right? And what you're doing is you're really just trying to replicate the factored form going backwards is all you're doing. Typically this is probably the quickest way if your number sense is good and the numbers are nice. The other way would be to use the box method. There's actually many more techniques. These are just the 2 I recommend because I know a lot of teachers here use them. So I'm going to use both methods. Okay, so I'm going to use the box method, and then I'm going to say reverse FOIL, really. So the box method works like this. Okay, the sum of the diagonals of the boxes should end up equaling your quadratic equation here, or at least the expression on the left-hand side. It should always be the first term, the second term, and the third term. Okay, and what we're really trying to find here, we're trying to find numbers right here and variables right there, that when you multiply them together, okay, so for example, in this box right here, this is going to be the product of these two values. And this should be a squared, right? So this should be a squared right here, because there's only one diagonal, one square. So the question is, what times what gives me a squared? That would be a and a. All right, and then I know that the bottom right square should be negative 7, because once again, that is only one diagonal, one box. And my options are kind of limited there. If I'm going to multiply 2 numbers together to give you negative 7, that's either going to be positive 1 and negative 7, or it's going to be negative 1 and positive 7. Okay? So I'm going to just try one of them. Okay, if I didn't know ahead of time, I was like, I have 2 options, I'm going to try something. I'm just going to pick the first one I thought of. 1 and negative 7. So now I can fill in the rest of the boxes. So the bottom left box is going to be multiplying a times 1, which is just going to be a. And the bottom, or the top right box will be negative 7 times a, which is just negative 7a. Now I just want to check to make sure that I have this middle term. So negative 7a plus positive a, that'll be, well, not positive 6a, that will be negative 6a, and I need a positive 6a. So how could I adjust this in order to make this puzzle work? Well, my first option did not work, so let's try the second option. And instead of erasing everything, I'm going to make that 7 positive. I'm going to make my 1 negative. That will change the contents of the box here. So I'll have positive 7a here, and then I'll have a negative a in the bottom left. So that will give me the like terms. 7a plus a negative a will give me positive 6a. So what this little puzzle did, it's really just a strategy to find out what my factors will be. So now I know that one factor is going to be a minus 1. The other factor will be a plus 7. And now I know that that's going to equal 0. And I know that either this has to equal 0, or this, or both of them. So I can solve these two equations separately. So therefore a is going to equal 1. Therefore a is going to equal negative 7. So now I know my answers. The FOIL method is really the same thing. It's just guess and check. What I'm going to look at here, if you want to stick to the actual acronym of FOIL, I know that this is giving me my first term, meaning the a squared term. So what times what will give me a squared, my first term in FOIL? Well, it has to be a and a. And I also know that the last terms will give me negative 7. So what times what gives me negative 7? Well, we can try I already know what they are, so I'm going to plug them in. Negative 1 and positive 7. Okay, so I just guaranteed the first term and the last term. Now what you want to check is the inside and the outside, the O and the I in FOIL. This is going to determine whether or not you have the middle term. So negative 1 times a will be negative a times 7 will be 7a. When you add those together, you'll see you'll get 6a, and it checks out. That's exactly what I needed. Okay, so there you go, another method to get to a factored form. And once again, you would solve this using the exact same strategy here, using the zero product property. All right, there you have it. On Tuesday, we're still going to be having an assessment. We'll have a little bit of time at the start of class to answer any questions you came up with over learning targets 0 or 3 regarding solving linears and linear systems, or whether you come across a snag and you need some help on quadratics, which you're going to work on today.